Hey, this is chapter 6.1 and 6.2. We're going to be covering rational exponents. So, section 1 is titled Evaluate nth roots and use rational exponents. So, an nth root, we have the nth root of a. This has the form of a radical, and a is the index of that radical. This can also be a raised to the 1 over n. So, with numbers, we have the cube root of a, or we can have a raised to the 1/3. Now, if n is odd, we have one answer, but if n is even, we can have one or two answers. So if you remember the concept of -2 squared being 4 and 2 squared also being 4, so therefore when we take the square root of 4, we have plus or minus 2. This is related. I'm going to actually be covering the n odd or even concept later in the chapter, but that's kind of a preview. So next we're going to go over rational exponents. And we can have either a raised to the m over n or a raised to the negative m over n. Now, the first one, a raised to the m over n, is the same thing as a to the 1 over n raised to the m, if we remember our properties of exponents, because the m will multiply by the 1 over n, which is m over n. So therefore, we can even simplify this further to have this form. Because these are equivalent. Next, we have a raised to the negative m over n. This is the same thing as 1 over a to the m over n, if you remember our properties of negative exponents. Therefore, we can have 1 over a to the 1 over n raised to the m, similar to our previous problem, and then this is our final answer, along with this. So let's do some practice problems. We have 16 raised to the 3 halves, or 3 over 2. This we can simplify to 16 to the 1 half, raised to the 3rd. So 16 to the 1 half, this is the same thing as 4. And we have 4 to the 3rd, which is the same thing as 64. Now if we want to write this in another form, we could have said the square root of 16 raised to the 3rd, which we would also get 4 to the 3rd, which is 64. Next, we have x minus 3 to the 4th equals 21, and we are told to solve. So we can raise each side, raise each side, yes, actually, to the 1/4. Or we could take this and write it as the 4th root. So either way, we have x minus 3 equals plus or minus the 4th root of 21. Therefore, we have x equals plus or minus the 4th root of 21. And remember, we have plus or minus because n is even. So we have plus 3. And then from here, since we have plus or minus, we have the 4th root of 21 plus 3 and the 4th root of 21 minus 3. So these are approximately 5.14 and 0.86 on our calculator. Section 2, apply properties of rational exponents. So the beginning is just a review from last chapter where we go over, say we raise a to the m and we multiply that by a to the n, that type of thing. And then we're going to add those exponents. So just going over the properties of exponents. So that would be chapter 5, and there's a section on that. So I'm not really going to go over that much in detail, but we do have this problem that we should use to review. So this problem is the same thing as 42 over 6. This whole quantity raised to the 1/3, and then squared. Then we have 42 divided by 6, which is 7. The 1/3 squared, which is 7 to the 2/3. So next we're going to be going over the properties of radicals. So this first problem is actually supposed to be a times b. So we have the nth root of a times b. And this is equivalent to the nth root of a times the nth root of b. So with numbers, for example, we have the third root of 12 times the third root of 18. This is equivalent to the third root of 216, which is the product of 12 and 18, which is 6. Next we have the nth root of a divided by b, which you'll probably think about in the same way. So we have the nth root of a divided by the nth root of b, in which b is not 0. So we can have the fourth root of 80 divided by the fourth root of 5. This simplifies to the fourth root of 80 divided by 5. So 80 divided by 5, that is 16. We have our fourth root, and this is 2. Add and subtract like radicals. So we have the fourth root of 10 plus 7 times the fourth root of 10. So we can group certain parts of this equation together. So we have 1 plus 7 multiplied by the fourth root of 10. Because they share the same radical, which is, as I keep saying, the fourth root of 10, we can group 1 and 7 together and then leave the fourth root of 10 to the side. So we get 8 times the fourth root of 10. So our second problem, we have 2 times 8 to the 1/5 plus 10 times 8 to the 1/5. Once again, we can group 2 and 10 together, and we just have 8 to the 1/5. And our answer is 12 times 8 to the 1/5. Whenever you share a like radical, you can group the problem together. So we have 2 and 10 and 1 and 7. So now I'm going to talk about the odd versus even exponents that I mentioned before. So we have our rational exponents of 7 and 4 here, and we have the 7th root of 5 to the 7th. Now this is 5, but if we take the 7th root of negative 5 to the 7th, we get negative 5. However, if we take the 4th root of 3 to the 4th, we get 3, and if we take the 4th root of negative 3 to the 4th, we also get 3. This is because negative 3 to the 4th, which is an even exponent, has the same product as 3 to the 4th, whereas there will be a minus sign if you have negative 5 to the 7th. 7 is an odd exponent.